morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. We have the spirit of mathematics. Rush has the spirit of the radio, a classic Rush song. You know it, you love it, just like mathematics. So let's get to it, shall we? We have the famous quadratic formula, which I'm sure you are familiar with. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. If we are in the form of ax squared plus bx plus c equals 0, that's important. It must be an equation. Oops, that's a mess up right there. And here, boys and girls, is the proof. Yes? So nice little proof. It just involves completing the square. I'm not going to go through it, but you should pause and take a look at it. So let's get to it, shall we? For using the quadratic formula, we have to have b squared. Well, if we're going to have rational solutions, b squared minus 4ac, the square root of it must be rational, which we're going to get to later in this video. So let's just get to it. You're going to use the quadratic formula if it's not factorable and if you don't want to complete the square, kind of whatever floats your boat. So in this case, x is going to be equal to negative b, so that's positive 2, plus or minus the square root of b squared, negative 2 squared is 4, minus 4 times a times c, all over 2a, which is 2 times 1. So that's going to be 2 plus or minus the square root of 4 plus 8 all over 2, which is equal to 2 plus or minus root 12 over 2, which is equal to 2 plus or minus, that's going to be 2 root 3 over 2, which we can simplify, dividing everything by 2 into what's that going to be? 1 plus the square root of 3. 1 plus or minus square root of 3. Okay. And I always like to show it graphically so we can show the solution. So I have graphed this, and here's what our solutions are, also known as the zeros. So 1 plus square root of 3 is approximately equal to 2.73. and 1 minus the square root of 3 is approximately equal to negative 0.732. So the next one, part B here, x is going to be equal to negative 3 plus or minus the square root of 3 squared, which is 9, minus 4 times a times c, all over 2 times a, or 2 times 2. So that would be negative 3 plus or minus the square root of 9 plus 32 all over 4, which is negative 3 plus or minus root 41 over 4, which cannot, root 41 can't be simplified. So those are our two roots, and graphically it's going to look like this. Okay, so negative 3 minus root 41 over 4 is approximately equal to negative 0.851 right there, the 0 right there. And then negative 3 plus root 41 over 4 is approximately equal to 2.35. So, moral of the story is, if a quadratic does indeed have real solutions, then it shall intersect or touch the x-axis. We'll talk about touch here in a second. And what's it going to look like if it doesn't have any real solutions? Does not have any real solutions? Well, let's solve this one. X is going to equal negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times 5, all over 2, which is negative 2 plus or minus the square root of 4 minus 20, is a negative 16 over 2. Uh-oh, we will not have a real solution, the square root of a negative number, right? So they solved it here, same way, I believe. Yep. And let's take a look at the nice drawings or the nice graph that they have here. In the real number system, root negative 16 does not exist. So we would say that this has no real solutions. It does have imaginary solutions, but we're not there yet. So if we graph this, look, it does not touch the x-axis. It does not cut the x-axis. So that's what the graph would look like. If the graph of a quadratic that has no solutions would either be like this, or it could be something like this, where it never touches or intersects the x-axis. And if you notice, that's going to occur when we have the square root of a negative number. So that's why something called the discriminant becomes quite powerful. And the discriminant is equal to b squared minus 4ac, because in the quadratic formula, boys and girls, remember, b squared minus 4ac is what determines what is housed within the square root. So if we can just we can tell a lot about the solution of an equation if we just quickly do b squared minus 4ac. So, and this discriminant is represented by the Greek letter delta. If delta equals 0, think about that. We would have negative b plus or minus the square root of b squared minus 4ac all over 2a. So if this is equal to 0, b squared minus 4ac, the discriminant, none of this matters because we're adding or subtracting nothing, and our solution is equal to negative b over 2a, and it's known as a repeated root, and we'll get to that in a second. If it's positive, then we have two distinct real roots because we can take the square root of positive numbers. If it's negative, we have no real solutions, just like we had before. And if they are rational, and if a, b, and c are rational, and delta is a perfect square, then we could have two rational roots, which we could have solved easier by factorization. So you should always check to see if you can factor a quadratic first. Okay. Use the discriminant to determine the nature of the roots of 2x squared minus 3x plus 4. So for a, delta, the discriminant, equals b squared minus 4ac. So that would be negative 3 squared minus 4 times 2 times 4. So that would be 9 minus 32. So I really don't care what the result is. I will say it's what, negative 23? All I care is that it's negative, so I have no real solutions. So what is that going to look like? It's going to be a parabola that does not touch or intersect the x-axis right here. So there are no solutions. No real solutions. No real solutions is the correct way to answer this question, to determine the nature of the roots. The nature of the roots is that there are no real solutions. Part B, delta, is equal to b squared, I'll go ahead and write it out again, minus 4ac, which is equal to negative 4 squared minus 4 times negative 1, which is equal to 16 plus 16, right? Yeah, which is equal to 32. So that means that we are going to have two rational roots. There are two, and distinct, meaning different, real roots. I shouldn't have said rational. Real roots. Because rational would mean that it can be written as a fraction, and that might not be the case. And so there we have it. It intersects the axis here, whatever that solution is, and whatever this solution is right here. Two distinct. 1, 2. Why do we have to say distinct? Well, it would help if we spelled it correctly, distinct, because they're different. And it is possible that you have a repeated root, and I think that's going to come up here, and it has a repeated root when the discriminant is equal to 0. Remember, because then it's just going to be, your solution is going to be negative b over 2a. So, if it has a repeated root, we need delta to be equal to 0. So we need b squared minus 4ac to be equal to 0. We need 6 squared minus 4 times k times negative 3 to be equal to 0. 36 plus 12k equal to 0. 12k equals negative 36. K is equal to negative 3. So that means that, replacing k up here in the original quadratic, negative 3 x squared plus 6x minus 3 equals 0. So it has a repeated root. Well, let's go ahead and solve for it. That's going to mean we can factor it and figure the solution. Factor out a negative 3, x squared minus 2x plus 1 equals 0. So negative 3 times x minus 1 times x minus 1 is equal to 0. So therefore x equals 1. And we say it's repeated because when you factor it, you get two factors. X equals 1 twice. So that's why we say that it has a repeated root. And what does that look like graphically? Boom chugga lugga lugga. This is where it touches the x-axis. It touches it. We don't say it cuts it. It touches it right there. And that is how we see the solution is x equals 1. And if you ever see it where the parabola just touches the x-axis, that is known as a repeated root or a double root. All right, hope you enjoyed it. I know I did. We shall continue at a later date talking about quadratics. Let's see how Rush is doing. Rush rules. Love him. You should go see him. I am